Hello everyone, this is section 2 of Terminology Leak Testing course. I am Parham, Ace into level 3 of leak testing. You can contact with me by these links. Even you can purchase my book on Amazon as a leak testing speed guideline. A special thanks to our financial support, Innotech CG. In this section, we talked about these words. Be familiar with them and their differences. Let's start with the meaning of each one. I will explain them after we learn the meaning of them in the next slide, and I talk about how to use them. Pressure above the absolute zero value, or pressure above that of a space empty of all molecules equal to sum of local atmosphere pressure and gauge pressure. I want to emphasize by underlining this part. As you see, about absolute pressure, it's equal to sum of local atmosphere pressure and gauge pressure. Why I underline this sentence? Because in the next slide I will talk about more about gauge pressure and atmospheric pressure in this slide and next slide. Absolute pressure, again I say absolute pressure, is sum of the gauge pressure and atmospheric pressure. This is the point that I want you memorize it and think about it during this section. Let's talk about absolute temperature. Absolute temperature is a temperature above absolute zero value. It's the same as the absolute pressure above the zero value. Absolute temperature is expressed as 0 Kelvin or minus 273.15 degree of centigrade or minus 460 Fahrenheit. Until we know the absolute pressure right now and absolute temperature. Let's talk about ambient temperature. Ambient temperature is temperature of surrounding atmosphere. Surrounding, also called atmospheric temperature. Okay, I will underline it. Atmospheric temperature or dry bubble. This is very important word. Dry bubble. Dry bubble is the most repeated word in the question of level 3 or level 2 or even level 1. When the designer want to trap you, want to confusing you. So now you know the dry bubble is the same meaning of the ambient temperature or atmospheric temperature. Dry bubble temperature is the same as ambient temperature or atmospheric temperature. Okay, let's atmosphere or ATM. For understanding the atmosphere, we need to know the standard atmospheric condition. It's the same as standard atmospheric condition. Before that, atmospheric pressure. We want to talk about atmospheric pressure. Ambient pressure caused by the weight of the Earth's atmosphere. Because the weight of the Earth overlying atmosphere decrease with increased altitude. Atmospheric pressure decrease with elevation, also called barometric pressure. So when you see a barometric pressure or atmospheric pressure, these two words is the same again. We have to memorize it. Atmospheric pressure is the same as barometric pressure. At the sea level, standard barometric pressure is taken as 101.325 kilopascals. So this is the base part of the pressure. As you come above the sea level, atmospheric is decrease. The pressure is decrease with increase above of sea level. The atmospheric pressure will decrease. It is also equal to pressure exerted by a mercury column 760 millimeter height. Actually is Hg millimeter height, millimeter of mercury. Call it millimeter of mercury in inches 29. Sometimes in a question let us 13 to better solving the problem, is equal to 760 millimeter of Hg or mercury or 760 torr. Okay, torr is one the pressure unit like Pascal or like mercury or inch of mercury or bar. These are the same. They are the unit of measurement of pressure. A standard atmospheric condition, that is the word that we talk about in atmospheric or atmosphere or ATM, that refer to this. Atmospheric pressure of 101.325 kilopascal, temperature of 0, the pressure is temperature is 0 centigrade or 273 Kelvin. This is a range of centigrade to Kelvin or Fahrenheit or range. The density of the air at this condition is at the sea level. This is the standard condition. Okay, about the standard, we talked about it in our last section, but I want to repeat it here. Standard, a physical object with known material characteristic used as a basis for comparison or calibration. references. Okay, these are the same sentence that I was talking about them in our last section. Is ambient pressure caused by the weight of the Earth atmosphere. As I told, the barometric pressure is the same as the atmospheric pressure in last slide. Partial pressure gas would exert if alone in a container, and working is a standard work pieces or energy source calibrated and used in a place of expensive reference standard. In calculation of photometers, the standards would be a light source. Okay, let's talk more about pressure. As you see here, 1 psi. Psi is one of the unit of pressure measurement as a Pascal. This is exchange of 1 psi to kilopascal. Each 1 psi is equal to 6.89 kilopascal. As atmospheric pressure to psi 14.7. Mostly in question, the designer let us 15 to make easy to solving the problem. 101 kilopascal, 764 or 1 bar. ATM in mercury, as you see in sea level, and the other exchange. And finally, the most important is SI unit for pressure is Pascal. When the designer do not let us the exact pressure measurement unit, we have to use Pascal. We have to change each of these pressure to Pascal, then calculate our and solving our problems. These are the temperature changes, as you see, ranking to Fahrenheit, Fahrenheit to Kelvin, Kelvin to ranking, and Fahrenheit, Kelvin to centigrade, centigrade to Kelvin, and Kelvin to Fahrenheit. These are the formula that you need to change each temperature to the other temperature unit. Absolute zero temperature is 0 Kelvin. When in a question talk about absolute zero temperature, we know is that question is talk about 0 Kelvin. 0 centigrade is the same and equal to 173 Kelvin, and minus 40 or 460 Fahrenheit is the zero ranking, and NTP is normal temperature 0 centigrade and 180. Till here, the slides that we talked about them was the basic for this slide. Here we want to talk about the very important thing that we call them PG or PSIG or PSIA, pressure of gauge or pressure of absolute. As in the first slide, I talked about the absolute pressure is pressure gauge plus the atmosphere. Until here, we understand the atmosphere pressure in kilopascal is 101 kilopascal. So here we understand the pressure of absolute is equal as a first slide that we talked about it, sum of the pressure gauge pressure and atmosphere pressure. So as we know, PAG or PSIG is a pound per square in a gauge. This is a gauge. As you see, this is a gauge. Gauge is like watch measure pressure inside or outside the system. You can understand how much the pressure is in your system or outside of your system. These devices we call the gauge. And PA or PSIA is pound per square inch absolute. And this PSIA is equal to pressure sound pound per pressure in inch gauge, or the pressure that gauge showing us plus 101 kPa or atmospheric pressure. Let's solving the problem, calculating the answer by this point that we learn until here about gauge pressure and ambient pressure and temperature, all of these words that we learned until here. A rigid constant volume system contains 100 standard cubic feet of air mass quantity at atmospheric pressure. Okay, as you see, 100 standard cubic feet it's volume at atmospheric pressure will be our P1 or first pressure. Assume uniform standard temperature and standard atmospheric pressure as 15 psi. Why I use 15 is here that the designer let us the pressure as a 15 psi. Okay, how much air mass in a standard cubic feet would the system contain at 13 psi g or gauge pressure? Okay, as we talked about in last slide, our P2 is our absolute pressure. That means this must be plus to 15. Our atmospheric pressure as the same as our first pressure in total. The PSIG is the only the pressure of the gauge what we are calculating in absolute pressure. So we have to add 15 psi, because atmospheric pressure is 15 psi. We add it to our gauge pressure and it's become 45 psi. So for calculating it, we have the formula for constant temperature, as it's talked about the question. Assume uniform standard temperature and standard atmospheric pressure, temperature and reach constant volume system. Figure out from this formula we need to have V2. If we send the other parameter to the other part of our equation, and just by calculating the formula and putting the numbers in the formula, we understand the V2 is 300 feet cubic feet. At the end, I want to appreciate you to watching my videos, and I want to ask you to subscribe my YouTube channel and support me. I want to have a special thanks to our financial support, Inotech CG. Have a nice time.